Hey guys, for our tutorial for Mech 410, we're going to be showing you the process of a ducted fan in a flow simulation with different configurations. From this, you should hopefully get a better idea of skills relating to simulation and configuration. So, first off, we are using a ducted fan in an enclosed space. Pretty simple. We've skipped, obviously showing how to assemble it, the mating, all that. Now, first step is to start the flow simulation wizard. And in this, we're just going to be naming it. This version has a static blade, so we're calling it with static blade. Kind of intuitive. And then we're going to be selecting our SI units next, after choosing our configuration being the current one, default name. And we're just going to be choosing standard units, SI. Now, we're using internal analysis with rotation as our physical feature, because thankfully, we are doing a rotation analysis. Now, you can see that we chose air as our gas, and we're just using the default flow characteristics for it. Now, with that in mind, we have the flow simulation wizard completed, which, as you can see, default settings for pressure. Now, next is to set up the mesh, the global mesh. Now, because this is demo, we don't have to go really high quality with it. We're just going to be going with a somewhat simple 4 for the global mesh, which after that, we're going to be setting up the rotating regions. Now, for the rotating regions, we established a cylinder feature, which has the blades wrapped around it. And this allows the front blades to rotate, and it's kind of just what we're going to be selecting here. Thankfully, it's all pre-made, so it saves us quite a bit of time. Choosing a shaft and cylinder, and this is just us going through the bodies to get to it. It's the Boss Extrude 5 and the evolving thing created. Now, here we're just going to be choosing the angular velocity of it. And we're choosing 7,000 rads per second. Kind of somewhat fast speed. And we're going to be setting up our boundary conditions. Now, because we don't want anything to go wonky with it, and by the way, we're doing environmental pressure here at 1 atmosphere, what we have to do is to avoid having issues conflicting. Here we're just going to be choosing our different faces. We have to choose the interior faces, not the exterior. So we click on each of the 6 faces for the cube, exterior, and select other, which is going to be selecting the inside face of it. Now, this means we're going to be using the internal surface as the boundary rather than the external, which is going to prevent some issues from happening. It's like a pipe, and as you can see, it fills up. And there's the mesh completed. So next step is to run the simulation, which is just being done now. And to save some time, first off, we're also making sure there's 4 CPUs selected for it. And we're just going to skip ahead a bit because it takes a bit of time, about 30 seconds. And then when it's complete, we have the simulation completed. And as you can see, we have a bunch of options in our results. So we're going to be choosing our flow trajectories and inserting a flow trajectory. Now, here we're selecting the starting point as the interior face directly opposite of the initial point of our ducted fan. And we're going to be set to have 300 arrows rather than the default of 20. And this is just setting up the transparency of the arrows. We don't want them perfectly solid, cause some issues. So we then OK it, and as you can see here, just getting through the progress, we have some errors of what happens. You can see the pressure going in. But now, this is the pressure trajectory. We don't want this. We need to change it over to velocity, which much prettier looking. It shows the velocity of the airflow. And it's a bit too high of a value, so we're lowering it to 150 meters per second, which, as you can tell, yes, the airflow definitely increases as it goes through the duct. it's the blades. Now, it also smoothed out a bit. So next up is to get another velocity one going. This is a 2D version of it. It's the same kind of thing, except instead of 3D, we have a 2D picture. This is a more even looking thing. It shows it in a bit higher detail. This is a cut plot, by the way, as opposed to the flow trajectory. Now, this, we're just lowering our minimum to 0. Makes everything nice and blue. And same upper. So, this is what it would look like if we had infinite arrows, basically. And if it wanted to show arrows that were completely useless. And that's the first configuration we're going to do. Now, next is, we're just looking at our configuration manager here. Just make sure everything's okay. So, we're just setting up the configuration. We're adding one. Now, this one is going to be for the same kind of thing, but without that, so, the front blade of this ducted fan is the dynamic blade, and the rear blade is the static. So what we're doing here is getting a static blade in order to show the difference for the configuration between them. Just to give a bit of a nifty little tutorial on it. Now, what we're going to be doing here is we have to adjust the model first, because otherwise we'd be using the one that has the static blade. So what we're doing here is we're just opening it up into Solidworks, just choosing our settings for opening. We weren't really sure what to do. We ended up realizing we have to change our configuration to the default here. And so what's going to happen here is we are looking for the circular pattern that involves our blades for the static one, which we do find. And I'm just going to quickly show you what we're actually doing. We are selecting the blades individually and suppressing them in, well, the specified configurations. Now, on right here, we made a small error. We chose the default configuration instead of creating a new one, which kind of causes a bit of an issue. So it's the default configuration here. Not good news for us. It can be fixed down the line, but so that's set up. Now we're going to be looking at we're adding the configuration here. I believe this was us fixing it. Now, this is the no static blade. We are finding the circular pattern that relates to this. And we're suppressing stuff for it. This is, see here, we recreated the new configuration. Now, this suppresses it. And we sadly had an extra blade showing. So, we kind of had to go and hide it. And this is just so static blades are gone. And as you can tell, we had a bit of an issue trying to get rid of it. Now, once we got rid of it, which I'll just skip ahead to about 10 minutes in, which is when we're done with this part, we're back to what we had before with it in the internal. And as you can see, we were just in the middle of updating it. And as you can tell, this is updated. We're missing the static blade now. And so that's the difference that happened. So original is with the static. This is without the static. That's the difference. And we didn't have to define anything new, thankfully. But we are creating a new project here in our configuration. And this is also no static blade in the fixed. I believe fixed is because we're doing this without a velocity, like simulating a wind tunnel. And this is just us okaying it. As you can tell, we only have the one. We made a bit of an issue with it. So we ended up changing it back to static and choosing the no static blade for our configuration. And we're changing the project over to no static blade because we made a boo-boo. And it's just asking if we want to reset the mesh settings, and nothing really special about that. We rerun the simulation, which takes a small bit of time. And so what we're doing here is just running it, getting it done. And it's done already, thankfully. And here is the difference in the cut plot being shown right now. and the difference in the flow trajectory. If you look earlier, you can tell this is definitely slower. The arrows coming out of the turbine, you can tell they're not hitting the static blade, so they're still rotating when they're coming out. Causes a bit of a little cool looking vacuum effect. Now, we have that. We're going to be doing it with a wind tunnel now. So what happens here is we go over to our properties, change the name, no static blade fixed. We now have the two configurations set up. Now, we have this facing in the X direction, so we're adding a 20 meters per second, that's about 72 kilometers per hour wind, just hitting it, or I can't remember, I think it's traveling into it or traveling against it. It's one direction in the X. Now, this is to show that it does work and our flow isn't just a bunch of nonsense. But as you can tell, this is the same kind of stuff going on, except now we have wind added, which causes the pressure to be a lot different looking and the velocity to be quite different. And we're just changing things over again, just to show what would happen if we did the wind tunnel with the static blade instead of without. And if you look here, we have the velocity and so forth without. And if we move back, you can see it with. So definitely a big difference between having no static blade and having a static blade in. And also showing off the pressure. So the main thing here is we have a flow trajectory, which is arrows, and we have a cut plot, which is a 2D image kind of deal overlaid onto it. And the big takeaway here is that we can tell, that's a really good one, by the way. This was actually the most surprising thing. You can see that the velocity ignores the cone for the most part, showing that our cone is actually a solid object and working. Now, the thing here, there's a few things to note between the static blade and the without a static blade, is that with the static blade and without the static blade, there is a small difference in the wind tunnel. It's hard to tell. The wind tunnel one has more of a downward shape towards the cone. But, see, if you look here, it's more straight. It's really hard to tell. It took quite a while for us to figure out the primary difference here. And so what we can tell from here, the takeaway, is that the condition in the wind tunnel was very similar to our condition in the default configuration. And this is the one with the static blade. But the fixed test, we can tell a huge difference. With the default, the velocity of the x-axis increases a lot, a very large amount. But in the configuration without a static blade, the x velocity does not change a whole lot, and this is because the main flow just rotates around the shaft rather than being corrected by the static blade. And so that's why when you compare the wind tunnel isn't going to be a huge amount of difference because the wind, of course, has its own speed, but the static blade does not. And with that, that's our entire presentation, showing that the difference between configurations and that they do make a difference, and showing how you can get a nice flow trajectory and cut plot going on. And here we're just fooling around with some of the visibilities of our static blade and non-static blade. And that's all there really is to it. We hope you enjoyed it, and as we also set the max velocity to 120 meters per second here. When we were testing this on our own, we had it at different values. About 130, 120, not really difference, but at 150, you can't really see a huge amount. This area at the front wasn't visible. It was the same color when it came to showing us the flow trajectory and the velocity one. So that's why we ended up lowering it here. And with that, we are done.